In today's lecture, we are going to see the next algorithm, that is the AdaBoost, which is the boosting algorithm. So, as we have already saw the boost, what is the meaning of boosting, right? So, what happened in boosting? Various slow learners we are finding on the given data set, and each of the new learner is based on the previous learner, because the errors of the previous learner will be overcome by the new learner or the new model, right? So this is how the boosting performs. So adaptive boosting or the AdaBoost is one of the simplest boosting algorithm. Usually decision tree are used for modeling over here. So multiple sequential models are created, each correcting the errors from the last model. Okay. सो यहाँ पे जो भी डिसीजन ट्री फॉर्म की जाती है, दैट इज़ इट विल बी फॉर्म ऑन द डिफरेंट फीचर्स. सो जितने भी फीचर्स उसमें होंगे, दैट मेनी डिसीजन ट्री कैन बी फॉर्म ओवर हियर. So AdaBoost assign weights to the observation which are incorrectly predicted, and the subsequent model works to predict these values correctly. Okay. So what this AdaBoost does, so ये क्या करता है, हर एक suppose in our data set 7 samples are there and 3 features are there. Okay. So for all the 7 samples it will assign the same weight at previously. Okay. Now after assigning the same weight to each and every sample, दिस इज़ द फर्स्ट स्टेप. सेकेंड स्टेप में वो डिसीजन ट्री फॉर्म करेगा फॉर ईच एंड एवरी फीचर. देन उसी डिसीजन ट्री और फीचर को स्टम्प बोला जाता है, और उसमें से बेस्ट स्टम्प चूज़ करेगा. ओके. और उसके बाद वो वेट्स कैसे असाइन करता है, दैट इज़ W इज इक्वल्स टू 1/n, विच इज़ नथिंग बट नंबर, n मीन्स नंबर ऑफ सैम्पल्स. ठीक है. सो एरर्स अगर पहले इसमें प्रेजेंट है तो दैट कैन बी प्रेडिक्टेड बाय द सेकेंड सब्सिक्वेंट मॉडल. ओके. सो लाइकवाइज, so that steps for performance of the AdaBoost are given over here. So initially all observation in the data set are given the equal weights as we discussed right now. A model is built on the subset of data. Using this model, predictions are made on the whole data set, right? So errors are calculated by comparing the predictions and the actual value. How we can calculate the error? By considering the actual value and the predicted values, right? So that is nothing but the output. Suppose in first model 5 samples we have considered, and from that 5 samples 4 are correctly classified and 1 is incorrectly classified. So that is nothing but the error. Okay. So while creating the next model, higher weights are given to the data points which were predicted incorrectly. So जो भी ये incorrectly predict किया जाता है उसको क्या दिया जाता है, higher weights, right? जब हम लोग next model construct करेंगे. So weights can be determined using the error value. For instance, higher the error, more the weights assigned to the observation that we discussed right now. This process is repeated until the error function does not change or the maximum limit of the number of estimators is reached. So जब तक ये एरर फंक्शन चेंज नहीं होता है तब तक यही स्टेप्स हम लोग क्या करेंगे, रिपीट करेंगे और नेक्स्ट मॉडल हम लोग फॉर्म करते जाएंगे. क्लियर? जैसे फर्स्ट इसमें एक डेटा सैंपल मिस क्लासीफाई हुआ था, एरर आया था. उसी एरर को हैंडल करने के लिए नेक्स्ट हमने मॉडल बनाया है, उसमें वो एरर रेट जो है वो कम हो गया, नेक्स्ट इसमें और कम हो गया. सो लाइकवाइज जब तक ये एरर मैक्सिमम लिमिट नहीं आ जाती है तब तक हम लोग उसे प्रोसेस करेंगे. So from the sklearn ensemble import, we are importing the data AdaBoost classifier model with the random state is equals to 1, and we are applying this model to the data set, that is X train and Y train, and to find out the score or the accuracy, we are applying the score on the x test and y test, right? So in first we are applying that model on the data set, and from the second we are calculating the score, right? So we are importing the AdaBoost regressor model, which is nothing but the AdaBoost regression model dot fit. We are finding first it is applying on the training data set. After that it is calculating the directly records or the score. Okay. Now there are certain parameters over here that we have to consider while looking for the AdaBoost. First is the base estimator. So which estimator we can call it as a base estimator? That is, it helps to specify the type of base estimator, that is the machine learning algorithm to be used as base learner, right? सो कौन सा बेस लर्नर सिलेक्ट होना चाहिए विच इज़ कॉल्ड एज द बेस्ट एस्टिमेटर, ये मशीन लर्निंग एल्गोरिदम उसे बताएगा. देन एन एस्टिमेटर्स, इट डिफाइंस द नंबर ऑफ बेस्ट एस्टिमेटर्स, कितने होने चाहिए वो डिफाइन करेगा. द डिफ़ॉल्ट वैल्यू इज़ 10, राइट. सो मीन्स कितने मॉडल्स बिल्ड होने चाहिए वो कौन बताएगा, एन एस्टिमेटर. सो डिफ़ॉल्ट क्या है उसके लिए 10 है. सो बट you should keep a higher value to get the better performance. Learning rate, this parameter controls the contribution of estimator in the final combination. There is a trade-off between learning rate and the n estimators. Maximum depth कितनी होनी चाहिए, that is it will be defined by the maximum depth of the individual estimator. n jobs कितने होने चाहिए, that will be decided by the number of processor it is allowed to use. Set the value to -1 for the maximum processors allowed. Random state, an integer value to specify a random data split. The definite value of random state will always produce same result if give with the same parameter and training data. So this is how the AdaBoost algorithm works. Okay, in next lecture we will see the next boosting algorithm, that is gradient boosting.